Hello guys, in this video I'm going to go over how to find the limits of rational functions. So when either the numerator or the denominator or both involves square root, like in this one we only got square root in numerator, it can be in numerator and denominator both, and when we plug in the x value and the rational expression turns into 0 over 0, then we're going to use this method to solve uh, these rational functions. It's 0 over 0 or infinity over infinity, let's say. Okay, so let's do a couple of examples. That way we'll be able to understand how to solve limits of rational functions. So this is the first example today I'm gonna do. Then we'll solve this one, third, fourth, and fifth. Okay, so like this example have square root in numerator as well as denominator. All right, let's start with the first example. So here we got limit x approaches to 0, square root of 2 plus x minus square root of 2 over x. So let's first of all plug in x0. So if we plug in x0 over here, we got square root 2 minus square root 2. That gives me 0 in the numerator and x is 0 in the denominator. So we got 0 over 0 form. So first of all, we're gonna rationalize the numerator. Okay, so what we're gonna do, let me write it down. So what we're gonna do, we're gonna multiply and divide by the conjugate of this. Okay, so we're gonna rationalize the numerator. So we got 2 plus x minus root 2 over x. So we're gonna multiply 2 plus x plus root 2 over root 2 plus x plus 2. Okay, so let's solve this. We're going to use some algebraic steps here. So as you see, this looks like a minus b into a plus b, which is equal to basically a minus b into a plus b is equal to a square minus b square. So we're going to use this identity over here. So our a is root of 2 plus x, so square of that will give me 2 plus x, and the square of b, which is square root 2, that gives me negative 2. And in the denominator we got x into root 2 plus x plus root 2. Alright, so let's simplify it. This gives me, forgot to put my limit. Okay, so limit x approaches to 0. So we got x in the numerator and we got x into square root of 2 plus x plus root 2 in the denominator. And we can cancel these x out. Okay, so let's do next step. So limit x approaches to 0. So we're left with 1 over root of 2 plus x plus root of 2. Okay, now we're gonna plug in the value of x into this expression. So that gives me 1 over root x approaches to 0. So that gives me root 2 plus 0 plus root 2 is equal to 1 over root 2 plus root 2, and this is equal to 1 over 2 into square root of 2. So that's the answer. All right, let's do next one. So next example we got 3 minus square root of 5 plus x and divide it by 1 minus square root of 5 minus x. So you see in this example we got square root in numerator as well as in denominator. So we need to rationalize both. But before that, let's find out if we get 0 over 0 form or not, like indeterminate form. So if we plug x is equal to 4 over here, so that gives me 3 minus square root of 4 plus 5 is a 9, and 1 minus square root of 5 minus 4 is 1. So this gives me 3, 3 minus 3 is 0, 1 minus 1 is 0. So 0 over 0. So that means we need to rationalize the numerator and denominator because both got the square root terms. Okay, so let's do that. So limit of x approaches to 4. So I'm going to write my numerator 3 minus root of 5 plus x. I'm gonna multiply it by the conjugate, so 3 plus root of 5 plus x, okay, and then 1 minus root of 5 minus x. Gonna multiply it by 1 plus root of 5 minus x. But we need to, if we are multiplying, I'm going to divide by this term too. I'm dividing by this term, I need to multiply this term too. So in the numerator, I'll get this term also, 5 minus x. In the denominator, I got 3 plus root of 5 plus x. Okay. So see, cancel out, we'll get the original function back. Alright, now let's do some math. So again, a minus b, a plus b gives me a square, which is 9, and b square is going to be minus of 5 plus x over, and I'm gonna write this part over to 1 plus root of 5 minus x, and in the denominator I got 1 minus 5 minus x into 3 plus root of 5 plus x, and again limit x approaches to 4. Let's simplify it and see what we'll get. So limit x approaches to 4. So I got 9 minus 5 minus x. So 9 minus 5 gives me 4. So I got negative x plus 4 into 1 plus root of 5 minus x. And over here I got 1 minus 5 plus x. So basically I got x minus 4 over here. Okay, and 3 plus root of 5 plus x. Okay, so let's simplify it. So if I take out negative here, then I'm left with x minus 4, 1 plus root of 5 minus x over x minus 4, 3 plus root of 5 plus x. So these two can cancel out. So we're left with, sorry, I forgot again, limit x approaches to 4. So limit x approaches to 4, I left with a negative of 1 plus root of 5 minus x divided by 3 plus root of 5 plus x. Okay, so now we plug in the value of x over here. Let's see what we will get. So we'll get limit of x approaches to 4. So if we plug in 4 there instead of x, so we'll get negative into 1 plus root of 5 minus 4 is 1, and we got 3 plus root of 5 plus 4 is a 9, and square root of 9 gives me 3. So in the numerator I got 1 plus 1 is 2, and negative sign, negative 2, and in the denominator I got 3 plus 3 is 6, and negative 1/3. So that's the limit of this function. Okay, let's do few more. Let's go over number 3. So here we got square root in the numerator. So first of all, let's plug in 3 and see instead of x. So 3 plus 3 gives me 6. So root 6 minus root 6 gives me 0 in the numerator, and 3 square, that gives me 9. 9 minus 9 is 0 again. So I got 0 in the denominator too. So let's solve this function's limit. Let's find out. Okay, so I'm gonna rationalize the numerator here. So limit x approaches to 3. So root of x plus 3 minus root of 6. I'm gonna multiply by the conjugate. So x plus 3, opposite sign, so plus root 6. And this can be written as x square minus 3 square. I'll tell you why. And then I'm gonna divide by same term, root 6. Okay, so limit x approaches to 3. So again, a minus b into a plus b is equal to a square minus b square. So a square is x plus 3 minus b square root 6 square, just 6. Okay, again, a minus b into a plus b is equal to a square minus b square. We are using this identity again and again. And in the numerator, so we're going to write the opposite of it. So x square minus 3 square can be written as x minus 3 and x plus 3 into root of x plus 3 plus root of 6. Okay, let's simplify the numerator. So 3 minus 6 gives me x minus 3 divided by again x minus 3, x plus 3 into square root of x plus 3 plus square root of 6. Okay, so these two will cancel out, gives me 1. So I left with the limit x approaches to 3, 1 over root of x plus 3 plus root of 6. Alright, so when we plug in x is equal to 3 over here, I got a square root of 3 plus 3 gives me square root of 6. So I got 1 over square root of 6 plus square root of 6. And yeah, I forgot one term over here. This one, x plus 3. Okay, so this is the one part, and x is 3, so 3 plus 3 is 6. So we got 1 over 2 root 6 into 6, or can be written as 1 over 12 root 6. So this is the limit of this function when x approaches 3. Alright, let's do a couple of more. So this one is, again, the square root is in the numerator. I'm going to write the conjugate of the numerator. Sorry, we're going to rationalize the numerator. Okay, so x approaches 0. When x approaches 0, let's check it first. So x is 0, 0. So I got root 1 minus 1, which is 1 minus 1, gives me 0 in the numerator. And x approaches 0, so I got 0 in the denominator too. Alright, so let's rationalize the numerator again. So we got limit x approaches 0, got square root of 1 plus x plus square root minus 1. Gonna multiply it by square root of 1 plus x plus square plus 1. Okay, so in the denominator we got x into, gonna divide by same term, we multiply the numerator with x square plus 1. Alright, so let's use the identity again, a minus b into a plus b. So square of this gives me, let me write down limit x approaches to 0. So I got 1 plus x square minus 1. Okay, so in the denominator I got x into root of 1 plus x square plus 1. Okay, therefore we got limit x approaches to 0. 1 cancel out. I'm gonna take x factor out here, so I'm left with x into x plus 1, because when I multiply the distribute, I'll get x plus x squared back. So write down everything together. Plus 1. This x will cancel out this x, so we're left with the limit x approaches to 0, x plus 1 over root of 1 plus x square plus 1. I'm gonna plug in the value of x is equal to 0 here, so we got 0 plus 1 over root of 1 plus 0 plus 0 plus 1 gives me 1 over, this gives me 1 plus 1 is 2, so 1/2. So the function, the limit of this function when x approaches to 0 is equal to 1/2. Alright, let's do one more, and this will be the last example. Okay, looks a little like you got two square root, like square root over the square root, you know. So we need to rationalize it twice. We need to rationalize the the numerator twice. You'll see how. Okay, so let's find out if it's 0 over 0 or infinity over infinity. So when x approaches to 2, so we got 2 over here. This gives me square root of 4, which is 2. 2 plus 1 is 3. So we got square root of 3 minus square root of 3 gives me 0 in the numerator, and 2 minus 2, 0 in the denominator. Okay, so let's rationalize the numerator. So we got a limit x approaches to 2, got 1 plus square root of 2 plus x minus square root of 3 over x minus 2. So we're going to multiply it by, let's put parentheses there. So we got square root of 1 plus square root of 2 plus x plus square root of 3. Same thing we're going to do in the denominator. So 1 plus 2 plus x and plus root 3. Good. Okay, so what we'll get over here? Limit x approaches to 2. So a square minus b square. So square of this gives me 1 plus square root of 2 plus x minus 3 over x minus 2 into square root of 1 plus square root of 2 plus x plus square root of 3. And when we simplify this, 1 minus 3 gives me negative 2. So limit x approaches to 2, we got root of 2 plus x minus 2. X minus 2 into, that's a big term, 1 plus root 2 plus x plus root 3. And if you notice, oh sorry, it's not on there only. Okay, so now again we still got square root in the numerator, so we're gonna rationalize the numerator again. So 2 plus x plus 2 divided by 2 plus x plus 2. Okay, so what we'll get over here? So limit x approaches to, so square of this, which gives me 2 plus x and square of this term minus 4, and in the denominator we got x minus 2 into square root of 1 plus square root of 2 plus x plus square root of 3 into root of 2 plus x plus 2. Alright, so if we simplify this, gives me limit x approaches to 2. So 2 minus 4, negative 2. So I got x minus 2 in the numerator, and also got x minus 2 in the denominator too. Let me write down everything. So square root of 2 plus x plus square root of 3 into square root of 2 plus x plus 2. So these two terms, these two terms will cancel out with each other. So we're left with the limit x approaches to 2, 1 over square root of 1 plus square root of 2 plus x plus root 3 into square root of 2 plus x plus 2. Okay, now we're gonna plug in the value of x is equal to 2 in this function. What you will get, let's find out. So here I got, if x is 2, so 2 plus 2 is 4. Okay, and square root of 4 is 2, and 2 plus 1 is 3. So I got square root of 3 plus square root of 3. And here I got 2 plus 2, again 4, square root of 4 is 2. and 2 plus 2 can be written like this. So this part gives me 1 over 2 square root of 3 into 2 plus 2 is 4, and which can be simplified into 1 over 8 square root of 3. So the limit of this function when x approaches 2 is equal to 1 over 8 square root of 3. Alright, so that's how you can find the limits of rational functions. So you can see square root in the numerator, in denominator, or both. Just need to rationalize it accordingly. Alright, thanks for watching the video, guys. Please share and subscribe to the channel so you won't miss the next video. Thank you again. Have a good day. Bye-bye.